Alright, guys, welcome back to our lecture series on information retrieval and text mining. We last time we talked on how we can create a vector space model. Now we continue again with some of the steps for creating a vector space model. The step one is pre-processing, and that is when we implement the processing functions which we have mentioned before. You tokenize, you remove step word, you do stemming. The input are our document, and the output are the token that we put into our index file. Uh, so the output does not contain any stop words or any punctuation, since we have done that all at the input. So this is how the step one looks like. We take all the tokens in the document as a bag of word. We created an inverted index, or what you know as the posting list, which we have discussed before. We convert them all to the lowercase, tokenize, remove stop word, and stemming. But something important here is that we lose the semantics. Immediately we turn the tokens in the document to bag of words, we lose the meaning, and we also lose the syntax. That's something that we lose as a result of this method. So text has sparse vectors, vocabulary, and therefore the dimensionality of vectors can be very large. Yeah, we know that we are taking the text uh, as each token is a what? Is a vector. Each token is a vector. Most document queries do not contain most words, so vectors are sparse, that is, most are entries. So the only way to do that is just to make a match between the document and the query, so the terms that are common that are in the queries will be our focus. The next is how we can build our inverted index, which we have done before, with an entry for each word in the vocabulary. Token obtained from the pre-processing mode, the output is the inverted index. We've done this before, and the data structure is a hash map, or we use dictionary in Python. Okay, so still we need one entry for each word in the vocabulary. For each entry, we keep a list of the document where it appears. Remember that we remove duplicates from each document. That is, if a token appears more than once in a document, we just count it as just one occurrence. But if it occurs in two different documents, we count it as two occurrences. Give the total number of documents in which the corresponding words appear, that is the document frequency, and we do the inverse document frequency, which is total number of document n divided by document frequency. It takes a constant time to find and update, since we are using an hash map. So these are inverted index, and this is what we're talking about. We keep a list of all the terms in our vocabulary. We specify the document frequency, how many times the word computer occurs in all the document. Then we specify the document in which it occurs. This is the posting list. We specify the document in which it occurs and the number of times it occurs in that document. So computer occurs in 3 different documents, but in document 7 it occurs 4 times. Database occurs in 2 different documents, but in document 1 it occurs 3 times. So the posting list gives us an elaborate of the number of times it occurs in each document. So this system occurs only once, that's why you have just one box, but in document 5 it occurs 2 times. So this is still the inverted index. For instance, we have document 1, document 2, 3, and 4, and each of these documents has the following text, which we break into tokens. So we can have all the tokens listed, So you have the one fish, the blue. Where's the blue here? That's not blue. Okay, there's blue here. So blue, you have the blue, you have the cat, you have egg. This has been stemmed. The S has been removed. We've removed it to the stem word. So we list all the tokens in the document in the entire corpus, and you will see that we take care of repetition. There are no repetition here. Then here we show where the number of times, this is the document frequency, the number of times the blue occurs in the entire corpus. So blue occurs only once, cat occurs only once, egg occurs only once, and fish occurs twice. So you see fish in document 2, and it occurs also in document 1. That's why we have 2 here. The others occurs only once in all the documents. But if fish has occurred also, like here, this is fish and this is fish, so we just count it as one occurrence. So the document frequency is actually for occurrence in 2 different documents, not the same document. When it occurs in different documents, that is when it counts. If it's the same document, it doesn't count. It only counts once. So, but in the posting list, we can now begin to now tell in which document it occurs and the number of times it occurs in that document. For instance, you can see fish. It occurs in document 1 and it occurs 2 times. You can see that. And it also occurs in document 2 and it occurs 2 times. You can see that. So all others occurs, green occurs in document 4 and it occurs only 1 time. So the indexing, how many passes through the data? So the time frequency and the inverse document frequency for each token can be computed in 1 pass. So we're trying to estimate the time that it will take. So if we take each document, we can get the time frequency, which is the number of times the term occur. We just pick each term, then we take all the document one after the other. Then we see the number, we pick document 1, how many times, like here. So we pick each term, and first of all check how many times it occurs in this document, so we know the number of times. Then we can also check how many times it occurs in the entire document. Or we can pick this document. You can pick document 1 and take the first one, count the number of times it occurs in document 1, list it, then go to document 2. You can check the number of times it occurs there, document 3, document 4. The same way, to calculate the inverse document frequency, we just need the number of times it occurs in the entire document. Cosine similarity also requires the document length. You need a second pass to compute the document vector length. Remember, the length of a document vector is the square root of the sum of the squares of the weight of the tokens. We have done this before when we were calculating the cosine similarity. And the weight is TF IDF. So we need to wait before you can know the inverse document frequency. You need to make sure that all the documents are indexed. Do a second pass over our document. Keep a list of the hash table with all the document IDs for each document. So what is the time complexity? Complexity of creating vector and indexing a document of tokens is big O of n. That is, for us to create a indexing a document of n tokens. So in a particular document, if we have n tokens there, So if we now have indexing m of such token, if we have m of it in a corpus, then that would be big O of m times n. That's intuitive enough. So computing token idea can be done during the same first pass. Vector length is also big O of n, and so the entire process take big O of m times n. The next stage is the retriever. So here in the retriever we have our input to be query, and we also convert the query into the inverted index, just like we did in step 2 for the document. We also do the same thing for the query. So we calculate the similarity measures between the query and the document. So we calculate the similarity values between the query and the document. Tokens that are not in both the query and the document have no effect on the cosine similarity. We talked about this before, so we focus more just on the tokens that are in the query because their product will be 0, so it doesn't contribute. So the query is fairly short, therefore its vector is extremely sparse. So we use the inverted index to find the limited set of documents that contain at least one of the query words. We said this before. So processing the query, we compute the cosine similarity of each index document as query words are processed one by one. Yeah, we mentioned this before. Cosine similarity of each index document. To accumulate the total score of each retrieved document, store the retrieved document in a hash table where the document ID is the key and the partial accumulated score is the value. So, what is the retrieval efficiency? Assume that on the average a query word appears in B document. So this query time Q1, Q2, Qn. So if it appears in all this document, then the retrieval time will be O of the size of the query multiplied by the number of documents it appears. Okay. So, and we know that the size of the query will be far less than the size of the entire vocabulary, and the size of the document it appears will be far less than the size of the entire document. So this is better than examining all the entire document. Step 4, and which is the final one, is you sort the hash table including the retrieved document based on the cosine similarity. The one with the higher cosine similarity will come first. Return the document in decreasing order from the highest value to the least value. The input is a similarity measure between the query, the output is a rank list in reverse order. So we're going to continue from the term weights in the next one. Thank you very much, and see you in the next one.